Welcome back, guys. Today we'll get 1B. Target 1B says I can rewrite expressions involving radical and rational exponents using properties of exponents. So we're still dealing a lot with our exponents. Before we get started, we do have some vocabulary to go over. So this symbol here is called a radical or a root. The number underneath is the radicand, also known as the base. Right, to think about what we were doing with exponents before. It's the radicand, also known as the base. This number here is called the index. And sometimes we'll have an exponent here. Right now, in this case, right, since we don't have one, it would just be 1. Right? So when I look at exponents, it's kind of the same thing. I still have that base. Okay? That index is just in the denominator of my exponent. And the exponent is just the numerator of my exponent. Okay? So I can switch between having something with a radical and having something with an exponent by following this. The base stays the same. The number on the left goes underneath, and the number on the right goes on top. So let's look at a few examples. All right. So radical to rational exponents, right? The exponent is the numerator, and the root is the denominator, okay? Or the index, right? We also, it's part of the root. So here, my base is 10, so that just stays how it is. Then my exponent is the numerator, and this is weird, the root is the denominator, but there's no number there. Well, our normal root, the ones you've probably heard of before, is a square root. So when there's no number for the index, it's 2. This is the only time it's not assumed to be 1, right? When there's no exponent, it's assumed to be 1. When there's no root or no index, it's assumed to be 2. Okay? So this is really the square root of 10 cubed, or square root of 10 to the third, is really 10 to the 3/2. Looking at example 2, I have 2, that's my base, right, whatever is under the radical. I have an index here, right, the number on the outside, but I don't have an exponent, so that's just going to be 1. Right? If I don't have an exponent, it's simply 1. So the 6th root of 2 is just 2 to the 1/6. Example 3, right? I have my base. The exponent goes in the numerator, so my numerator is going to be 5, and my root goes in the denominator, so my denominator is going to be 4. Right? So 2 to the 5/4. For example 4, right? My base is 5. My exponent is 5, so that goes in my numerator. And my root, or my index, is 4. So that goes in my numerator. So this is 5 to the 5/4. For example 5, Now we have variables, but they work the same way. My base is m. My exponent is 3. Right, so that goes in the numerator. And then my root is 4. So this is just m to the 3/4, right? The 4th root of m cubed, or to the 3rd, is m to the 3/4. Now one thing, in our next example, we have two things inside our radical. So two things are our base. So both 6 and x are our base. Both of those have to be raised to the power. So when I have more than one thing, I have to put them in exponents so that you show that both of those are being raised to the power. So then my exponent is 4. Right, so that goes in the numerator. And my index, or my root, is 3. So that goes in the denominator. So the cube root of 6x to the 4th is 6x to the 4th third. Alright, go ahead and pause the video and try these next two problems on your own. We'll go over them tomorrow in class. When you're done, play the video. Continue to play the video so we can go on to the next section. Alright, looking at our next section, now we're just going to flip the other way, right? So we went from radicals to rational exponents, right? So radicals to exponents. And now we're going to go from exponents to radicals. So it's the same thing, you're just flipping the process. Alright, so let's take a look. Here, my base is 7, right? The numerator is 1 in my exponent, and the denominator of my exponent is 2. So it's the same thing. That base stays as the base. That numerator is still my exponent. The denominator is still my root. The only thing about this one is, remember, square root is just your normal root. You don't need to write the 2. An exponent of 1 is just your normal exponent. You don't have to write it. So if you have something like this, I'm really just writing it here, the square root of 7. So be careful with those things that are understood to be there. Remember, 2 can disappear from here, and 1 can disappear from there, because they're understood to be there. Alright, looking at example 8, right? 4 is my base, so 4 goes in my base. 2 is my numerator, so 2 goes as my exponent. And 3 is my denominator, so it goes as my root, or the index. Right? It's the cube root of 4 squared. Let's look at example 10. 2 is my base, 5 is my exponent, and 5 is my numerator, and 3 is my denominator. So I always have to start for these ones by writing the radical, because I'm switching to radical form. 2 is my base. 5 is my exponent, right? And 3 is the number out in front. This is the cube root of 2 to the 5th. Same thing for this one. Both 5 and x are being raised to that power. 5 is my numerator, and 4 is my denominator. So when I write my radical, since both 5 and x are being raised to that power, both 5 and x have to go underneath. Then, 5 is my exponent because it's in the numerator, and 4 is my index, or root, because it is in the denominator. That's where we're going to stop for today, guys. Hope you have a wonderful evening.